and relative density. Density rho of an object is the mass of the object m per unit volume v, or rho equal to mass of m over v volume. The unit is kilogram per meter cube, that is kg per meter per cubic meter. Relative density (RD). Relative density of a substance is the ratio F, the mass of any volume of it, to the mass of equal volume of water. Relative density RD is equals to mass of substance over mass of equal volume of water. Relative density has no unit since it is a ratio of similar quantities. In this case, two masses. Archimedes' principle. Archimedes' principle states that when an object is wholly or partially immersed in a fluid, it experiences a loss in weight or an upthrust which is equal to the weight of the fluid displaced. Apply it to relative density, RD will now be. Apply it to relative density, RD, we have that relative density equals to weight in air over apparent loss in weight in water, or relative density equal to weight in air over upthrust in water. Law of flotation. This states that when an object floats in a fluid, upthrust exerted upon it by the fluid equal the weight of the object, or it states that a floating object displaces its own weight of the fluid on which it floats. Example 1. A solid weighs 4.8 grams in air, 2.8 grams in water, and 3.2 grams in kerosene. Calculate the ratio of density of the solid to that of the kerosene. Solution. Mass of solid in air equals to 4.8 grams. Mass of solid in water equal to 2.8 grams. Mass of solid in kerosene equal to 3.2 grams. Relative density equal to weight of solid in air over apparent loss of weight in water. Relative density is equal to 4.8 over 4.8 minus 2.8, which is now give us our relative density as 2.4. Relative density equals to weight of kerosene over weight of water in the same volume, which is equal to 4.8 minus 3.2 over 4.8 minus 2.8, which will give us 0.8. Density of solid over density of kerosene will now be equal to 2.4 over 0.8, which is equal to 3. The ratio of the density of solid to that of kerosene is 3:1. Example 2. 40 cubic meter of liquid P is mixed with 60 cubic meter of another liquid Q. If the density of P and Q are 1.00 kg per cubic meter and 1.6 kg per cubic meter respectively, what is the density of the mixture? Solution. Mass of liquid P equals to volume times density, which is equal to 40 times 1, which will give us 40 kg. Mass of liquid Q equals to volume times density, which is equal to 60 times 1.6, which is 96 kg. Mass of the mixture is now equal to 40 plus 96, which will give us 136 kg. Volume of the mixture equals to 40 plus 60, which is 100 meter cube. Density of the mixture equals to mass over volume, which is 136 over 100, which will give us 1.36 kilogram per meter cube. Example 3. An empty relative density bottle has a mass of 20.0 gram. When it is filled with petrol, its mass is 55.0 gram. Calculate the mass of the bottle when it is filled with water. Relative density of petrol equals to 0.7. Solution. Let the mass of water filling the bottle be x gram. Mass of petrol filling the bottle is equal to 35 gram. Relative density RD of petrol equals to mass of petrol over mass of equal volume of water. Replacing the unknown values, we have that the relative density equals to 0.7 equals to 35, which is the mass of the petrol, all over S. Making S the subject of the formula, we have that you cross multiply, you have 0.7 times X equal to 35.0. S is equals to 50 gram. Mass of relative density bottle full of water now be equal to 50 plus 20, which will give us 70 gram. Example 4. A block of material of volume 20 cm cube and density 2.5 gram cm per cm cube is suspended from a spring balance with half the volume of the block immersed in water. What is the reading of the spring balance? Density of water equals to 1.0 gram per cm cube. Solution. Mass of the block equals to its volume times its density, which is equal to 20 times 2.5, which will give us 50 gram. Upthrust equal to weight of the water displaced, which equals to loss in weight in water, which is equals to 10 cm cube times 1, which will give us 10 gram. Therefore, reading of the spring balance is equals to 50 minus 10, which will give us 40 gram. Example 5. A piece of cork density 0.25 times 10 raised to power 3 kg per meter cube flows in a liquid of density 1.25 times 10 raised to power 3 kg per meter cube. What fraction of the volume of the cork will be immersed? Solution. Let the total volume of the cork be VTM cube. Let the volume of the cork submerged be Vs meters cube. Mass of cork equal to 0.25 times 10 raised to power 3 times Vt kilogram. Weight of the floating cork equals to weight of the liquid displaced, that is 0.25 times 10 raised to power 3 times Vt kilogram equals to Vg times 1.25 times 10 raised to power 3 kilogram. Fraction of the cork immersed equals to Vt over Vs, which is now equal to, in bracket, 0.25 times 10 raised to power 3 divided by, in bracket, 1.25 times 10 raised to power 3, which will now give us 1 over 5. Example 6. A hydrometer of mass 3.60 kg